So I welcome you to this material science class. We already seen something about the crystallography. The regular arrangement of atoms exists in salt and some metals. We already seen that in the whole arrangement of atoms in the crystal, this fundamental unit called unit cell, and we have seen different types of unit cell. And in the study of unit cell, we are going to study something more. So I want to revise and I want to continue further. Please closely follow me. Thank you. Whenever the dimensions of the unit cell vary, the angles and the length, breadth and height vary, then there are different types of unit cells which are found by the Bravais. So by his name, the Bravais lattices, triclinic, monoclinic and orthorhombic. In orthorhombic there are 4 types, so in which all the sides are not equal but all the angles are 90. So in such case there may be simple cubic cell and face-centered cubic cell and body-centered and end-centered. So these are the various types. And similarly tetragonal. In this one, symbol tetragonal, and there may be body-centered tetragonal, rhombohedral, hexagonal and so on. Cubic. So whenever the angles are varying, the sides are varying, we have classified into different types. This thing we have seen in the last class. So here we have seen the 3 main types of unit cell. Simple, in which there are only 4 corner atoms. The only corner atoms at the end of the corner, in which 1/8 of the atom is projecting inside and the remaining will be projecting outside. Maybe one body center fully is at the center apart from the corner atoms. So the corner atoms, and in the case of face-centered cubic structure, in each face there is one atom which is in which half of the atom is projecting inside and half of the atom is projecting outside. So 1/8 of the atom lies at each corner. So totally 8 corners. So in 8 corners, 8 into 1/8, totally it's equivalent to 1 full atom. And in the case of body-centered cubic cell, 1 full atom is there at the center of the unit cell, and at each corner 1/8 of the atom is projecting inside. Therefore, 1 full atom is there. On all corners there will be one atom. So totally 2 atoms. In face-centered cubic structure, in each corner 1/8 of the atom is projecting inside, and each face is half of the atom is projecting inside, and therefore in all 6 corners there will be half of the atom is projecting. 6 into 1/2, 3. 3 plus all corner atoms 1, so 3 plus 1, 4. And today we are going to see the various crystal defects. It may be called as defects or imperfection. Whenever the atom is displaced from its position, then there is said to be some defect. This may take place at a particular point or a particular line or particular plane. So according to these things, they are called as point defect or line defect or planar defect. The defect which occurs at a point, it's called point defect. The defect which occurs along a line, that's called as line defect. There are defects which occur along the surfacial defects or planar defects. So whenever some impurity atom enters inside and replaces the original atom, it's called substitutional defects. In the figure, we see one yellow color atom is inside, it's foreign atom, it's an atom of some other material, but it has entered into this material. For example, in the case of ruby, some chromium atom, aluminum atoms are there, one particular atom is missing, and in that place, some other atom is there, so substitutional defects. Interstitial defect, when the atom enters and is placed internally at some other place without replacing the parent atom, it's called as interstitial defects. So there is, whenever the atom is missing at a particular place, it's called as vacancy. ஒரு பர்டிகுலர் பிளேஸில் ஆட்டம் இல்லாமல் இருந்துச்சுன்னா அது வேக்கன்சி. அண்ட் whenever the atom enters in between some other atom, it's called interstitial impurity or interstitial defect. So the atom has entered interstitially in between the some other atoms. Whenever the ionic compound is considered, there may be positive ion and negative ion, for example sodium chloride. Whenever a positive ion escapes out due to some external force, then negative ion also escapes out due to get neutrality. In order to get neutrality, negative also goes out. So in that case, it's called Schottky's effect. Another one is Frankel effect. Whenever the atom is displaced from its place and it enters interstitially to some other place, ஒரு இடத்துலேருந்து போய் அடுத்த இடத்துல வேறு எங்கேயாவது போய் அதே அரேஞ்ச்மெண்ட் ஆஃப் இடத்துல வேறு எங்கேயாவது போய் இருந்துச்சு அப்படின்னா இட்ஸ் கால்ட் அஸ் Frankel effect. So whenever Frankel effect is there, it's got low coordination number, large difference in sizeல மாறுபடும், அப்படி பல different defects may occur. Here you can see the ionic compound, some plus atoms generated by pink color, and another one negative, it's generated by blue color. When a particular atom is missing, a particular atom is missing in its place, then the property of the material may vary whenever large amount of defects occur like this. So in this place, some dotted line that indicates some missing of certain negative atom, blue color atom is missing there. So whenever it may occur due to some external force applied on it, and also whenever the negative ion escapes out, then one positive ion also escapes out due to attain neutrality. So here there is in the left hand side another dotted line that indicates another missing of positive ion. This is called Schottky's effect. Whenever when atom is when atom is there is not there particular place, then it is non-stoichiometric compound. If it is if it is indicated by some color in which the vacancy occurs, it's called metal deficiency defects. Positive and negative ends are there, A and B, and in a particular place the atom A plus that's not there, it's missing. So that's called metal deficiency. Whenever the atoms are displaced along a particular line, then the nearby lines are also moved slightly, and the arrangement of atoms is affected, in which shear stress is produced. This type of defects are called line defects. So the line defects may occur along a particular grain boundary. Grain boundary is nothing but the line which encloses the grain inside. Grain is nothing but a group of atoms which forms a particular particle of the body. And whenever the atoms are displaced similar to thread of the screw, it's called screw dislocation or screw defects. In the figure you can see, instead of displacing straight, it's displaced along slightly, it's an inclined form. It looks like screw thread. It's called, and whenever this one occurs at the edge, it's called edge. It may be called as edge dislocation. Next one is planar defects. The atoms are arranged in a particular plane. Whenever the external force is applied, the planes are moved out of its alignment. It's called stacking fault. The atoms may be displaced along a plane which passes through grain boundary. It's called grain boundary defect. Then the atoms are arranged in square packing form or hexagonal packing form like this. Depending upon the number of atoms surrounding a particular corner atom, then it may be called as coordination number. In case of simple cubic structure, around a particular atom there are 4 atoms are surrounding it. It's called, the coordination number is 4. In the case of body centered cubic structure, 4 corner atoms are surrounding the body centered atom at the top and the bottom. So hence total number of atoms are 8. So it's called, coordination number is 8. In the face centered cubic structure, the particular corner atom is surrounded by 4 face centered atoms at its plane, and another 4 atoms in the vertical plane, and another 4 atoms in the perpendicular plane to the previous vertical plane. So hence the total number of atoms surrounding it is 12. Therefore coordination number is 12. These are the various types of coordination numbers. So this way we shall continue in the next class. Thank you.